All right, let's start our third video on this unit. And this third video is going to look at what happens when we keep our A value at 1, but we add or subtract a C value. Now, the first thing I want to tell you is that we're going to talk about a formula for finding all of this information as we go through this week. So the observation that I want you to really make today is that the only thing that's different is that now I have a plus 5, or I have a C value. So let's fill that in first. That C value of 5 means that my y-intercept is now at 0, 5. So we can put that point in right away, 0, 5. Let's deal with our A value now. The A value, the number in front of x squared, is a positive 1. Positive tells me that it opens up, and I have a minimum, a low point in my graph. Now this vertex value, we're going to start looking at a formula later this week for finding it. Actually, we'll probably look at it tomorrow. But the vertex this vertex has only been shifted up or down because all we've changed is the C value. So I'm going to give it to you for today. When I only change the C value, my vertex becomes 0C, because that's all I've changed, which means that my axis of symmetry is still at x equals 0. Notice we have to have the x equals. So we've got that invisible line, or that imaginary line. And since my vertex is at 0, 0, it goes first in my table of values, 0, 5. And then remember, I can count up or I can count down. Because -1 and +1, -2 and +2, -3 and +3 are going to give me the same value. I want you to stick in your head, though, that I said count up or count down from your vertex, because your vertex is not going to stay at 0 for long. So be careful with that. Now we need to do some work to find those other values. In this case, we need to take our x value, square it, then add 5. So 1 squared plus 5 is 6. 2 squared, then add 5, that's 9. 3 squared, then add 5 is 14. So that we have the point 0, 5 for our vertex, the point 1, 6, and the reflection, remember that means also -1, 6, because it's across that axis of symmetry, 2, 9, and that means -2, 9, because it's across the axis of symmetry. And that 3 point we're not even going to worry about because it's not going to fit on our graph. Remember to sketch it in as a curve. And how does this graph compare to the parent graph? It has been shifted up. It's been a shift up. Now problem number 4 is now a subtraction. What do you think that it's going to be in comparison to the parent graph? Yep, you're right. It shifts down. Would you please take a moment and try and fill in number 4 and sketch its graph? Okay, so hopefully you filled all of this in, and I want to throw that caution out to you one more time that that C value really only affects the y-intercept directly. Everything else is not quite as clean as this is. So the C value affects, most importantly, the y-intercept. Changing that y-intercept so that it's no longer 0, 0 can also be called a shift or a vertical shift, shift up, or shift down. We're going to take this in piece by piece this week. So hopefully these pieces get you started, and I will see you for 10.2 where we start talking about B and what it controls. But I bet you have an educated guess about what we haven't done with our parabola yet.